Hello everyone, in today's video I'm going to upgrade the ThinkPad X61. First, to be clear, even after the upgrade, the performance will still be too poor to be used as a daily driver machine for many people. This video also does not cover all the possible upgrades that you could do to X61, so this is not a comprehensive guide. I know some people have dug much deeper into this topic than me, and some would disagree with what I've done. This video is primarily just to document what I've done to my own X61, not a guide about how everyone could or should upgrade theirs. I'm happy with the result and hope you would enjoy it as well. I'm aware of the X62 and X63 motherboard upgrades, and in fact I own both of them, but they will not be discussed in this video. I'm going to upgrade the following aspect of the machine: install the SSD, replacing the memory, installing the IPS or AFF screen, mod the LED backlit, and finally upgrade the processor. First, the hard drive and the RAM. X61 originally came with a spin drive. Replacing that with SSD would give a huge performance lift. As for the RAM, X61 came with 1GB or 2GB standard. Here I'm installing the maximum RAM capacity supported by chipset, which is 8GB. After replacing the RAM, we could see 8GB RAM in the BIOS, as well as in the operating system. Next is installing the IPS screen. X61 was born in 2007. It was kind of rare to use an IPS panel on a laptop back then. While some of the ThinkPad models have the IPS screen options from factory, the X61 didn't. Only the X61 tablet had the IPS screen. So what we are going to do is essentially mod the IPS screen for the X61 tablet into an X61. Unfortunately, it wasn't straightforward. For most machines, installing an IPS screen is as simple as taking it apart, removing the old screen, and putting in a new screen. There are two issues here. The first is that 12-inch IPS screen has a different pinout than the stock TN screen. The second is that all the 12-inch IPS screen has different mounting holes than the TN screen. Or I should say, all the 4x3 12-inch IPS screens were designed for tablet PCs, came with a digitizer, with mounting holes on the tabs, so quite different from the ones used in laptops. But while that's all fine, they could be modded. The pinout issue could be resolved with a converting cable, which could be bought online, but you could also make yourself. For installation, I've got tapes, a pillar, and a saw. Before modding, plug in the screen and make sure it works. The first is to remove the digitizer behind the screen. There is not enough room for it in the X61. Then remove the mounting tabs, and they interfere with the case of X61. The last is the frame. Notice the frame is designed to accommodate the digitizer, so it's fairly thick. The extra portion needs to be removed. And now it's ready to be installed back. If you are satisfied with the brightness and the color, then this should be it. I have another machine with an IPS screen modded. The screen I had for that one has aged a lot. It's dark and yellowing. It became quite obvious when comparing side by side. So I'm going to install an LED backlight for that machine. I'm using a generic LCD stripe I got online. However, this is not the best choice as LEDs are a bit too separated. I've tried to make my own, but turned out it's not easy to find a PCB manufacturer that would take orders for these long and thin broads. I'm worried about that the cheap generic LED driver board would have flickering issues due to PWM, so I made my own. I used Monty's TLD3 design, redrew that in KiCad. Technically, it still uses PWM, but it's filtering the PWM signal into a DC value and doing a voltage division between and the feedback voltage into the DC-DC regulator. The LED stripe takes 9V at 600 mA. Before installing back into the screen, also remember to test it standalone. The installation is nothing more than removing the old SCCFL tube and inserting the LED stripe. So, time for a comparison. It's much brighter than the new CCFL tube. If you often need to use a laptop in bright environments, like maybe outdoors, the additional brightness is pretty useful, and because it no longer flickers, it might cause less eye strain compared to later LED ThinkPads like X201S, 220, 230, 240, and X250, the list just goes on. Okay, that's for the screen part. Now let's go on to the CPU modding. When purchasing X61 new, one would have the choice of either a 65nm or 45nm processor. X61S only came with 65nm options. But if one is buying used units in 2021, then well, good luck. In practice, it's not that easy to come by a 45nm X61, and it's even harder to find a T9500 X61 with 6MB L2 cache. The X61 I have came with a 65nm processor, so trying to upgrade the processor myself is a much more reasonable option than trying to buy a high-spec one. Here is the list of the processors supported by the 965 chipset. Low-end processors are not listed. I'm going to upgrade anyway. Note the processor in the X61 is sorted down to the motherboard using the BGA package, but most of the processors one could buy is in the PGA package and are supposed to be plugged into a socket. Some of the higher-end P-series processors had only the PGA option but not BGA. Some of the CPUs that requires a 266 MHz bus clock require overclocking the motherboard, as the X61 only supports 200 MHz clock by default. The processor I'm going to install is the P9700, and that's the fastest 25-watt processor. Hopefully, the 45nm and lower TDP could mitigate the heat dissipation issue of the stock X61. The first issue to be resolved is the BIOS. The BIOS of the X61 couldn't support the newer 45nm CPU very well due to the lack of some microcode. The modding process is basically backing up the current BIOS, extracting that, patching the module to manually add the necessary microcode, packing up the BIOS again, and force splash the new BIOS. The details are described in my blog, or you can just download the modded BIOS online somewhere. Next is the frequency. I mentioned X61 only supports a 200 MHz base clock, but the processor I'm going to use expects 266 MHz. If the machine detects a 266 processor, it refuses to boot. So the mod is to fool the NOS bridge to make it think the processor is 200 MHz, but still letting the clock generator generate a 266 MHz clock. But there's the catch. The RAM would end up running 33% higher frequency. For example, if the memory is designed to run at DDR2 667, it would need to be running at DDR2 888. Well, 888 isn't that bad for DDR2, but keep in mind it's configured to use a timing of 667, but not 800. The solution is to mod SPD. SPD is where the memory stores the timing configuration. The plan is to mod the SPD so the RAM report itself as a 533 MHz RAM module with CL5, then BIOS will set the frequency to 533 and CL5. The real frequency is 33% higher, so it's really DDR2 708 with CL5. It's still slightly overclocked, but generally it works well. This needs to be done when the PC is still running, or you could use another PC to mod it. In the X61, access to SPD EEPROM is controlled by 1 GPIO. Use hardware everything to enable the access, then the SPD2 could be used to read the SPD. I'm not going to the details of the modding process, but they could be found in my blog and other resources online. One thing I want to point out is make sure to use RAM modules that doesn't have EEPROM write protection. If there are 2 RAM modules installed, only one needs to be modded. Now, the RAM modules are ready as well. The next issue is about how to install the processor. As listed before, P9700 only has a PGA version, but X61 only accepts a BGA processor. What should I do? Well, PGA processors have pins, but BGA ones don't. So the first step is just remove all these pins with a soldering iron. But this is not enough. Comparing with a real BGA processor, one will notice the pads on the PGA processor are much larger. If I try to rebuild this processor, the balls are either shorting with each other or not tall enough to reach the motherboard. The solution is to add another pass-through interposer PCB in between. First balling both sides of the interposer, the process is the same as reballing any other BGA chips. Once that's finished, put the X61 motherboard onto the preheater, remove the old processor, clean the pads, and finally solder on the interposer and the processor. It still won't boot. I mentioned before I need to fool the NOS bridge into thinking the base clock is 200 MHz. The NOS bridge uses a B cell or frontside bus sense pins to detect this base clock frequency. The goal is to let the NOS bridge receive 010 and let PLL receive 000. On the motherboard, it's surprisingly easy. Just short these 2 points and this would pull out B cell 1 only at the NOS bridge side. Now assemble everything back together, plug in the power supply. It should power up automatically as the CMOS has been cleared. It will reboot once itself, then the screen would come up. I'm not going into benchmark details, but there could be up to 2x uplift in the performance. Though this is about the end of this video, well, it probably doesn't look too complicated, but I end up spending a lot of time on it. I guess by the end of the day, I have finished something that I've been wanting to do ever since I bought my first X61 more than 10 years ago. See you in the next video.